Hello all, good morning. Welcome to Unacademy. Now we'll crack GATE and ESE with India's largest learning platform. Yeah. So before going to start this, let me introduce myself. Dhanashree Mam. I completed my MSc in Mathematics from Mumbai University and also having 13 plus years of teaching experience. I mentored more than 10,000 plus students for the engineering. Okay. Now here, these are the steps how to install the Unacademy's learning app. First, go to your mobile's Play Store app, then search Unacademy's learning app, then select your goal, take your any subscription plan, either for plus subscription, iconic subscription, okay, or free classes. It is up to you. Now here, what you will get on this Unacademy's platform. Okay, so you will get a daily live classes, chat with your educator, engage in discussion, ask your doubts and answer the polls while the class is going on. And second one is live test and quizzes. You can evaluate your preparation with our regular mock test and quizzes and get the detailed analysis on your performance. Now third one is structured courses. So you will get all our courses are structured in a line with your exam syllabus to help you the best prepare for it. And next is unlimited access. One subscription gets you access to all our live and recorded courses to watch from the comfort of your any devices. Okay. Now here we will see the what includes the iconic subscription plan, why the iconic subscription plan is best for you. Okay, it includes the personal coach, get one-on-one guidance from the top exam experts as your personal coach, align your preparation strategy and learning resources here. Okay, now here it means you can ask your doubt from your direct to your personal coach. So this is very important benefit of iconic subscription. And here is mains and question and answer practice also going on. Strengthen your mains answers writing through the regular practice with an evaluation and personalized feedback. Okay, now here is study tracker. You can get participate in study tracker plan and study booster workshop. Evaluate your progress in a bi-weekly reviews with the personal coach. All benefits of plus. This is very important. You will get the all benefits of plus subscription in the iconic subscription. Okay. Now what are the benefits of plus subscription? Again the same here, daily live classes, but here you will not get a personal coach, so that is the important benefit of iconic subscription. So daily live classes are there, chat with your educator, engage in discussion, ask your doubts and answer the polls while the class is going on as like a special classes. Now the live test and quizzes, evaluate your preparation with our regular mock test and quizzes and get detailed analysis on your performance. Now structured courses, all our courses are structured in a line with your exam syllabus to help you the best preparation for it. Now unlimited access is there. One subscription gets you access to all our live and recorded courses to watch from the comfort of your any of your devices. Okay, here I'm going to tell you you can learn on the Unacademy's platform with the best educators of Unacademy. For example, here is Maruti Tiwari sir, Ankit Goyal sir, Jaspal Singh sir are here. So these are help you to take your study on the next level. These are also some. Now here GATE and ESE courses, the structured courses are here, batches and year-long courses. So there are many courses for the each and every batches here. Now here GATE and ESE subscription, you can see the plus subscription. First is India's best educators, you will get it. Then next is interactive live classes, structured courses and PDFs and live test and quizzes. Now iconic subscription, you will get India's best educators here. Then interactive live classes, structured courses and PDFs, live test quizzes. Now personal coach you will get in the personalized test analysis, study planner, preparatory study material also you will get. Now the plus subscription. So what is the plus subscription plan? Here if you take the GATE and ESE subscription, so you will get a plus subscription plan for the 12 months. It's a benefit for you if you take a 12-month subscription plan, so that you can prepare in a very well mannered. So the cost for the 12 months plan is 30,250, but if you use my promo code, that is DSP, then you will get a 10% discount on your subscription fees. So you will get it here 27,225. Okay. Now here we will go for the iconic subscription. So same here. So here for the 12 months, the subscription plan for iconic is 50,250. But if you use my promo code DSP, you will get a 10% discount on your subscription plan. So it will goes to you 45,225. So what you are looking for, you enroll your names today only, and the batches are going on from the today itself. Now involve here batch C for the civil engineering with the top educators of Unacademy, and it started from the 25th of January, that is today. For you will get a 10% discount on your subscription plan here if you use my promo code DSP. Now here the new batch alert for the GATE 2023 for the civil engineering, also starting from the 25th of January. So enroll your name here. Now here for the chemical engineering, the batch A is also start for the GATE 2022. So you can enroll your name here. Now here batch C is also starting from the mechanical engineering. So you can enroll your name here from the today itself. So go fast and enroll your name. And you will get a 10% discount on your subscription plan if you use my promo code DSP. Okay, now let's start our actual topic. Okay, so I know you are waiting for this. The actual topic is trees here. So we will see the definition of tree here and some examples depending on this. So definition, a graph is acyclic if it has no cycles. Okay, so what is the definition of a tree? A graph is acyclic. So we have seen many lectures on the discrete mathematics here. I think this will be our last or probably second last lecture on the discrete mathematics. So I cover up each and every point from the discrete mathematics. You can go through it if you want to understand any one of your topic from the discrete mathematics. Okay. Now, a graph is acyclic if it has no cycles or circuits. A tree is a connected acyclic graph. Okay, acyclic, it means there is no cycle. So suppose this is your graph, right? So this is connected acyclic graph. This is connected acyclic graph. This graph is known as tree. Okay, this is connected acyclic graph is known as tree. So here, so connected acyclic graph, you can see this is a tree. There is no cycle in this graph. So this is your tree. Okay, or like this, like this. Okay, now every tree has some roots. Okay, every tree has some roots. So you can see that the root is here. This is your root of the tree. Okay, so this is the root of the tree. Now see, if J is a tree, and then if and only if there exists a unique path between any two vertices of a G. So we say that any graph is a tree if there exists a unique path between any two vertices of a graph G. Okay, now let's see here, if eccentricity of the vertex. So these are the examples of tree. So eccentricity of a vertex. What do you mean by eccentricity of a vertex? Let's see. Here, eccentricity of the vertex, the distance between any two vertices in the connected graph is the length of the shortest path between them. Okay. So eccentricity of the vertex, it means the distance between two vertices. We can see here distance between two vertices. Here distance between two vertices in a connected graph. In a connected graph is a graph of is a length of the shortest path between them, is the length of the shortest path between them. Okay, so we can find out the eccentricity of every vertex from the graph. So eccentricity of the vertex is nothing but the shortest path. It means maximum distance between u and v of all u in G. Okay, so we'll see the eccentricity of a vertex. Suppose this is your graph. You can see the graph. There is vertex A, B, C. Here is D. I, C, A, B, C, D. Then F. We can see here is F. Then G. Here is H. Okay, so M. C, A, B, C, M. Here is I. Okay, so I, J, K here. Then A, B, C, D here, F, G, H, M. So we can find out the eccentricity of the vertex A. It means the shortest path between the vertex A to the, now we will find out the length of the every vertex. So eccentricity of A. It means maximum distance. Here we can see that the maximum distance from the vertex A to the remaining vertices. Okay, so maximum distance between the vertex A, here other vertices speak to you, for all V in G. So there are many vertices. So we can find out the maximum vertex. So eccentricity of a maximum distance. So A to B 1, A to C 1, 2, A to D here is 2, A to F 3, A to H here is 4, A to G here is 4, A to M here is 3, A to I here is 3, A to J here is 4, A to I here is again 4. So what is the maximum distance from the A to the remaining vertices is 4. So eccentricity of vertex A is 4. Okay, so eccentricity of the vertex A. So you will get eccentricity of vertex A is 4. Now eccentricity of vertex B. Now find out. B to A 1. B to C only 1 edge. Now B to D 1 edge. B to F 2 edge, 3 edges. B to H. So similarly you can find out the eccentricity of every vertex is here. Eccentricity of B is 3. Then eccentricity of C is equal to 4. Eccentricity of D is equal to 2. Eccentricity of M is equal to 3. Eccentricity of I is equal to 3. Eccentricity of J is equal to 4. Eccentricity of K is equal to, you will get 4. Eccentricity of, eccentricity means what? Maximum distance of that vertex to the remaining vertices. Okay. So you will get here eccentricity of G. So what is the eccentricity of G? Here 1, 2, 3, 4. So eccentricity of G is 4. Eccentricity of H 1, 2, 3, 4. So eccentricity of H is also 4. Eccentricity of F is equal to 3. 1, 2, 3. Okay. So eccentricity of every vertex from the remaining vertices. Okay. Eccentricity of that vertex, the longest path, maximum distance from the vertex to the remaining vertices is the eccentricity. Now center of a tree. Now we will see that here, center of a tree. So what do you mean by center of a tree? Center of a tree here is the vertex with minimum eccentricity. Vertex with a minimum eccentricity is the center. So which vertex is having minimum eccentricity? Which vertex is having minimum eccentricity? D. So D is our center. Okay. So D is the center of the tree, because minimum eccentricity of the vertex is 2. Okay, so D is eccentricity of D is equal to 2 is the center of the tree. Now level and height of a tree. So what do you mean by level and height of a tree? So here we can see that the level and height of a tree. So a vertex V in a rooted tree is said to be at level n if there is a path of length n from the root to the vertex V. Okay, so level of the vertex, there is a path from the vertex V in a rooted tree. There is said to be a level n if there is a path of length n from the root to the vertex V. So we can see that suppose this is your root, A is the root, B is the vertex, here I, Z, here is C, here is G, K, H, I, M. Okay, C, E, N, P. You can see that the vertices here F, Q, R. Okay, so A, B, C. Now see the level of the vertex. Level of the vertex is at a path along path of length n from the root of the vertex. Now this is the root of the vertex. Now see the level of A. Here level of I. So the level of I is here 2. Okay. So level of I. So vertices of length level 2 are 1, 2. So I, Z, G, E. These are the vertices at level 2. Okay, these are the vertices at level 2. Now we can see that the vertices K, H, N, P, F at level 3 R, Q, M, I at level 4. Okay, so now length of the length and height of a tree. So the maximum level is 4. So height of the tree is 4. Maximum level is 4. Maximum level is 4. So height of the tree is 4. Okay. Now next, emery tree. So what do you mean by emery tree? An order tree in which every branch node has at most m sons is known as emery tree. At most m sons. See, suppose this is your tree. So this is m sons or 0 sons. So here at most. So this is your ternary tree or three-ary tree. Ternary tree. Okay. This is your ternary tree. Now binary tree. It means every vertex has at most 2 sons. Okay. So every vertex has at most 2 sons or 0 sons. So you will get here binary tree. So this is our binary tree, right? So this is binary tree. Every vertex having at most two or two cells. Okay. Now we will see the Huffman coding algorithm. Okay. So we will see the Huffman coding algorithm here to find out the optimal binary tree or optimal tree. So let W1 Huffman coding algorithm. What's that algorithm? Huffman let W1, W2, W3 and so on be the weights of the leaves, and it is required to construct an optimal binary tree. Now step 1. First of all, arrange the weights in an increasing order. Step 2. Consider two leaves with Consider two leaves with minimum weights W1 and W2. Replace these two leaves and their father by leaf and assign to this new leaf the weight W1 plus W2. Now step 3. Repeat step 2 for weights W1 plus W2, W3, W4 and so on until no weight remains. The tree obtained in this way is an optimal tree for a given weights. Okay, is an optimal tree for a given weights. Now, build a Huffman tree for the following frequencies of 6 letters. So, first of all, what is our step? First of all, arrange these weights in a ascending order. Okay, so we will arrange the weights in ascending order here. Okay, so weights. So minimum weight is 4. So the S is 4. Here after that I 5. After that O 7. After that T 8. After that P 12. 29. Okay, now see, add weights, these two weights. So add, you will get here the smallest 4 plus 5. 4 plus 5. So 4 is to the left, S, and is to the I is to the left. So 0, 1. Okay, so you will get SI. So reduce to 9, right? So again we will prepare the table, right? So here you will get O 7, P 8, SI 9, then P 12, E 29, right? So we'll get again OT. OT will get 7 plus 8. 7, 0, 8, 1, right? So you will get this OT. Now next table you will get, now the frequencies are 8 plus 7, 15, right? So here 9, 12, 15. So we can write it here, the table as 9, P, 15. Here is 29, right? So SI, so take the, okay, so find out the sum of this. So 9 plus 12, 9 plus 12, so you will get here is 9 and here is 12, right? But how 12 is only 9, it means here 0, 1, Here 9 it means what? 4 and 5. So you will get here is 0, 1. 9 it means 4 plus 5. 4 plus 5 it means what? What is the weight of that? Is 4. We can write it here SI. Hmm. And here is SIP. Here is P. So S and I. Okay, that's it. Now SI it means S and I. Now next here next table will be 9 plus 12. So 21. So you will get the arrangement of your OT first. Right? OT is 15, then 21, but 21 it means what? SIP. And here is E29. So we can write here OT plus SIP. OT SIP. Here is OT. Here is SIP. Here is O. Here is T. Here is SI. Here is P. S I. Okay. So OT SIP. Here is 0, 1, 0, 1. Left 0, right 1. Left 0, right 1. Now everything is OT SIP. So OT plus SI is done. So what is remaining only? 15 plus 20. Right. Now next is here 15 plus 21 is done. Here 15, 21, 21 it means SI and P. Okay. Now next is E. So you will get E29 plus 36. In the next table you will get 29 plus 36. So here is E. So you will get OTSIP E plus EOTSIP. Right? So here is E 0. Here is OTSIP. So here is OT. Here is SIP. Here is O. Here is T. Here is SI. Here is P. Here is S. Here is I. Right? So 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. So we can write out the prefix code for this. So we can see here prefix code for S. S is 4. So here 1100. So prefix code for this 1100. Prefix code for I 1101. 1101. Okay. O 100. T. Here is 101. P 12. 111. E 29. Here is 0. Right? So this is your optimal binary tree or optimal code optimal tree by using Huffman coding algorithm. Are you getting it? How to find out the optimal prefix code by using Huffman coding. Now next is, if you want, we can take them one more example also here, or otherwise we'll go for this. Okay, so we can see here, for the following set of its, construct an optimal binary prefix code for following set of codes weights, construct an optimal binary tree, optimal binary prefix code for each weight in the set give corresponding code word. Okay, we will get it here: 5, 7, 8, 15, 35, 40. Right? So find out the optimal prefix code for this. So you will get ascending order. All the weights are in ascending order. So you will get 5 plus 7. Right? Here is 5. Here is 7. 0, 1. Right? Now 5 plus 7 is 12. So you will get the weights are 8, 12, 8, 12, then 7 plus 5, 12, 8, 12, 15, 35, 40. 15, 35, 40. 8, 12, 15, 35, 40. Okay. Now next is, here you can see that here 8, 5, 7. Next is here 12. So 8 plus 12. So you will get it here 8 plus 12. Five, 7. So you will get it here 5, 7. Now arrange this: 8 plus 12, 20. So 15, 20, 35, 40. Right? So 15, 20. So 15 plus 20. 15, 20. 8, 12. 5, 7. No. Next we will get Now 15 plus 20. 15, 20. 20 is 8 plus 12. 12 is 5, 7. 0, 1. 0, 1. 0, 1. Right? So the optimal prefix code. Now the remaining is 12 plus 30 is 35. And original 35 is also there. So we will get 35, 35, 40. Okay. Here is 35, 35, 40. So you get 35, 35, 40. It means the previous 35. So it means 70, 35. And here is 35. Right? But this right side of 35 is left side of 55 is 15 plus 20. Here is 8 plus 12. And here is 5 plus 7. Hmm? Okay, so you can write down the prefix code for each. So it's 70 plus 40, 110. 40, 70, 35. Here is 35. Here is 15. Here is 20. Here is 8. Here is 12. Here is 5. Here is 7. Okay. So we'll get 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. Right. So what is the prefix code for 5? Code for 5 is 10110. Right. 10110. For 7, 10111. For 8, 1010. Prefix code for 12, 1011. Prefix code for 20, 101. Prefix code for 15, 100. Prefix code for 35, 10. Prefix code for 35. Prefix code for this 35 is only 11. And prefix code for 740 is 0. Clear? No. We can find out the tree traversal. Okay. What do you mean by tree traversal? It means how to find out the tree traversal, then spanning tree. So tree traversal. There are three standard ways of traveling the tree with a binary tree T with root R. Okay. So three standard ways are: first is pre-order traversal. Okay. First is pre-order. Pre-order traversal. Hmm? Pre-order traversal. So the algorithm for this is pre-order traversal is: first process the root, Second, traverse the left subtree. Traverse the left subtree of R in pre-order. Traverse the right subtree. Traverse the right subtree of R in pre-order. Okay. Now it means first process the root, then subtree, left subtree, then right subtree. Okay. Now here, suppose this is your tree. Root. Okay. This is your left subtree. This is your right subtree, left subtree and right subtree. Okay. Now next is in order. We will find out all these things in one example only. Now in order traversal. So in order traversal, first is traverse the left subtree. Traverse the left subtree of R in order. Sec B, process the root. Traverse the right subtree of R in order. Okay, traverse the right subtree of R in order. Okay, now third one is suppose this is your root. If you see, this is your root. Then left subtree, right subtree, and the same process. Third one we will see post order traversal. There is post order traversal. Okay. So post order traversal is here A. The traverse the left subtree in post order. Right. Second, traverse the right subtree of R right subtree of R in post order. And C, process the root. Process the root. Now, if you see the example here, okay, first pre-order of T. Okay, pre-order of T. So here first of all, in pre-order what we will do? First of all, process the root. then left subtree. Okay, so root is A, then left subtree, same the root is B, then left subtree, then root is E, then left subtree, then I, then C, I, C, and then F. Okay, and last is G. So first of all, first process the root, then left subtree, then right subtree, then left subtree, then root, in that way. Second one, in order. In this, first process the left subtree, then root, and then right subtree. Right? So the process left subtree, D, root B, then H, then E, then I, then root A, then E, okay, sorry, then F, okay, then F, then G, then C, C, then G. Okay. No, third one, post order. Post order traversal of T. So in this, root is processed at the last. So first left subtree, right subtree, and then root. So left subtree, so here is D, then right subtree, then again root, then here E, I, then E, then B, then F, then G, then C, and then A. Okay, so here is root. If you see, root is first, root is middle, root is last. Okay, post order, in order, pre-order, in order, post order. Pre-order, in order, post order. Okay, now next is spanning tree. Okay, spanning tree. Here we can see that spanning tree. A spanning tree of a T is a connected undirected graph G. Is a tree composed of all the vertices of the edges. Informally, spanning tree of a G is a selection of edges of G such that the edges of G that from the tree span the edges of the tree, edges of G from the tree spanning every vertex, that is every vertex lies in the tree but no cycles are formed. Okay, so spanning trees of a graph G. Now suppose graph is given. It must contains all the vertices. Okay, this is a graph. So this is graph G. Suppose spanning tree of G. This is spanning graph of G or spanning tree. Acyclic connected acyclic graph. It covers all the vertices but not all the edges. So this is a spanning tree of the graph G. Okay, so minimum spanning tree. So there are two algorithms to find out the minimum spanning tree. Okay, so two algorithms to find out the minimum spanning tree. First is Prim's algorithm. Okay, Prim's algorithm. In this algorithm, let G be a G is equal to vertices of P and H set of E be a connected weighted graph. Be a connected weighted graph. We construct a minimal spanning tree we construct a minimal spanning tree T for G inductively as follows. Step 1. Here take a vertex V0 in graph G. Take a vertex V0 in graph G. Okay. Set T is equal to V0 and phi. Okay. Step 2. Find edge even. Find edge even, which is equal to V0 V1 in E such that its one end vertex V0 is in the set T and its weight is minimum. Now set T is equal to V0 V1 E. Step 3. Choose next edge EK is equal to VK comma V such that its one end vertex VK is in the set T and other end vertex VL and other end vertex VL should not be in T. Okay. Add vertex VL to the vertex set of T and H EK to edge set of T Step 4. Repeat step 3 until T contains all the vertices of G. Okay. The set T now gives the minimum spanning tree of the graph. Set T gives minimum spanning tree of G. Okay. Now see here. So we will see stepwise construction of the minimum spanning tree for the following graph using Prim's algorithm. So for example here, give the stepwise construction of minimum spanning tree for the following graph using Prim's algorithm. A to E is 11 weight. Here is B. B to A is 9. B to D is 2. D to F is E. 7. Here is 2. Here is 6. Here is 8. B to F is 8. Okay. Here is B to F is 8. Okay. A minute. No. To find out the construction for the by using Prim's algorithm. Step 1. Stepwise construction we have to give. So here step 1 is T is equal to singleton A and phi. Let's start with vertex A. Now step 2. Minimum weight from A to the remaining vertices is 9. So reach from A to B. 9. Right? Now T is equal to here AB E1. Next step 3. What is your step 3? Now from B to the remaining vertices, the minimum weight is D. So reach A to B, A to B, B to D. That is 2. So T contains A, B, D, E1, E2. Okay. Now step 4. A to B. Now D to the other vertex is A to B, B to D, D to E. Minimum weight is 2. Right? So T contains A1, B1, A, B, D, E. E1, E2, E3. Step 5. Okay. From E to C with the minimum weight E to C. Now C. No, we will not find out the circle. Okay. Now choose the any other vertex, that is D. So here D contains A, B, D, E, C, E1, E2, E3, E4. Okay. Now step 6. A, B, 9, B to D, 2, D to E, 2, D to F, 7, E to C, 5, right? So T contains A, B, C, D, E, C, F, E1, E2, E3, E4, E5. Now step 7. In the vertex A to B, 9, B to D, 2, D to E, 2, E to C, E to C, 5, C to 9, sorry, C to G, 10, and the remaining vertex is A to D to F, that is 7. So this is your minimum spanning tree. It covers all the vertices and the graph is obtained with minimum spanning tree of weight. Now we will calculate the weight. This is the minimum spanning tree. Minimum spanning tree of weight. Here 7 plus 2, 9, 9 plus 9, 18, 18 plus 2, 20, 30 plus 5, 35. Right? So with the minimum weight 35. This is the minimum spanning tree. This is the stepwise construction of a minimum spanning tree by using Prim's algorithm. Okay. Now we'll see the Kruskal's algorithm. So here we are going with the, here we use a vertex. Okay. And go to the next vertex, right? Now here in a Kruskal's algorithm, what we will do, we will pick up an edge. Then we will pick up an edge. Okay, now let's see the Kruskal's algorithm. Here is Kruskal's algorithm. Okay, let G is equal to VE be a weighted connected graph. Be a weighted connected graph. Be a weighted connected graph. Step 1. Here, pick up an edge EI. Pick up an edge EI of G. Pick up an edge EI of G such that its weight of EI is minimum. Okay. Step 2. If edges E1 and E2 up to En or Ek, if edges E1, E2, E3 up to Ek have been chosen, then pick up an edge ek plus 1 such that first one ek plus 1 is not equal to ei for any I varying from 1 to k. Second, the edges E1, E2 up to ek plus 1 do not form a circuit. Okay. Third one, the weight W of ek plus 1 is as small as possible subject to the condition 2. Step 3, there is, you can say here step 3, stop when step 2 cannot be implemented. Stop when step 2 cannot be implemented. It's very simple. In a Prim's algorithm, we will go by vertex with the minimum weight. Now here we will go edge by edge with the minimum weight. Okay. So we will solve an example here. Give the stepwise construction of minimum spanning tree minimum spanning tree for the following graph. For the following graph. For the following graph using Kruskal's algorithm. Okay. E to E. Okay. A to B is weight 10. A to C is 2. B to E is 5. B to C is 5. C to D is 2. D to E is 4. E to F is 10. A to F is 4. And here D to F is 6. Here C to E 4. Here is B to F 9. Okay. Now we'll see the stepwise construction. Step 1. Here A to C with the minimum weight. You can see A to C is A to C with minimum weight 2. Now from C to the remaining vertices, end vertex is here. So C to D. So step 2. A to C, C to D, C to D. Step 3. Here is A to C, C to D, and A to F. Step 4. A to C, C to D, D to E, 4. Then A to F, 4. Okay. Now you can see the first minimum weight A to C is 2, from C to D is 2, from D to E is 4, from A to F is 4 and D to E is 4. Then which vertices are remaining? Only all the vertices are covered. B is remaining. Okay, so it is B here. So step 4 is done. Now see the step 5. Now only the vertex B is remaining, so you can reach by step 5 here. You can reach by vertex C to B with the weight 5. C to A weight 2, A to F weight 4, then C to D weight 2, D to E weight 4. Okay, so you will get the weight of these vertices are. So with this is the graph is a minimum spanning tree. This is minimum spanning tree. Minimum spanning tree with weight here 4 plus 4 8, 8 plus 2 10, 10 plus 2 15 plus 2 17. So the minimum weight is 17. Okay, so this is a minimum spanning tree with a weight 70. I hope you are getting it clearly, each and every part of this tree. So I will try to cover only by taking one example here. So every part I covered over here. So tree. Now max flow and mean flow cut is remaining. If time limits permits, we will take that max flow and mean flow cut in the next lecture. Okay. So thank you so much. Keep watching. If you are liking my videos, please do like, share and subscribe. And don't forget to hit the bell icon for the further notification.